Hey guys, Buildzoid here, and today we're going to be taking a look at the RX 6800 XT Speedster Merc 319 PCB from XFX. And before we get into this, I'd like to thank Tech PowerUp for providing high-res PCB pictures in their GPU reviews, because that's where these PCB pictures are from. So there's a link to their review of this card down in the description, which you should check out if you care about things like power consumption and temperatures and performance and, like things that aren't just power delivery and like capacitors, which is actually just part of the power delivery. So I just said power delivery twice. Good job, me. So anyway, yeah. So that's that. Thanks to Tech Power Up for the pictures. There's a link to their review down in the description. And the other thing I would like to like to get out of the way before we, well, actually, no, it's going to come up throughout the video, but it does not elude me how pointless it is to do PCB breakdowns of RX 6800 XTs, considering that AMD has decided that you're not allowed to overclock the memory by more than like 7.5%, and you're not allowed to overclock the core by more than, I believe, like 30%. So, it might even be less than 30%. Like, basically, there's horribly low clock speed limits on the RX 6800 XTs. So, as fancy as some of the PCBs are, like, say, this one is, well, it's not really fancy, but it is really nice. So, like, the difference between fancy and nice is, like, if it was really fancy, there'd be, like, I don't know, they do something wacky like an all ceramic output filter instead of using any polymers, which would be super expensive, and they're not doing that because it would be ridiculous. But, um, well, but it is a really nice PCB. Yeah, so it does not elude me that a nice PCB like this is kind of wasted on a card where you can overclock the core to, like 30, like by 30%, which you can honestly, like, you can max out the core on water cooling, if you get lucky with the silicon and that kind of thing. But you can definitely max out the core on water cooling, and then you can max out the memory with actually without doing anything to it, really. Like, it's just the 7% memory frequency increases. It's just like, that's not much overclocking headroom you've got there, AMD. Why do you keep making bad decisions? Can you not just make like one good product without doing at least one thing wrong at the same time? Anyway, let's get into it. So in typical RX 6800 XT fashion, we've got power delivery on either side of the GPU core. On the left side, we've got 5 phases of Vcore, so that's that. And then we've got 2 phases of SoC below that. Then below the 2 phases of SoC, we've got a 0.75 volt rail, which if AMD ever removes the clock speed limits, might be worth messing with if you're on liquid nitrogen, to see if you can like maybe move the cold bug or improve the cold cold behavior. Because this rail sometimes does that on some AMD GPUs. Well, the equivalent of this rail, because in the past that rail would be like, if you go far back enough, it would be like 0.9 volts instead of 0.75 volts. But anyway, yeah, this rail might like on ambient, it's basically like it exists. It doesn't do anything. You don't have to worry about it. Then there's a 1.8 volt rail over here, which I believe is so it's definitely used for providing the VPP voltage for the GDDR6 memory chips. But I think it's also used for powering the BIOS chip, because GPU BIOS chips normally run off of 1.8 volts. And usually there's like, well, there's some cards where you'll have a 1.8 volt LDO specifically for the BIOS, and then another 1.8 volt regulator for the memory chips. But like, considering where that 1.8 volt regulator is, I feel like it's probably powering that BIOS chip as well. Anyway, so that's the left side of the card, and then on the right side of the card, which is significantly more important. Well, it's not really more important, but anyway, on the right side of the card, we've got our memory power delivery. So you've got 2 phases of VMEM. Under the 2 phases of VMEM, you've got 1 phase of vddci, so that's memory controller power, and then below that, we've got 9 more phases of Vcore. So the Vcore VRM on this card is a 14 phase, the SoC VRM is a 2 phase, the memory VRM is a 2 phase, and the vddci is a single phase, which is the standard, normal phase counts for, well, let's just go to the back of the card. So all of those phases are controlled by these two chips over here. The top one is an IR35217. The 35217 is in charge of the memory power. So it's running in 2+1 phase mode, which is mega overkill. Like using a 35217 for a 2+1 phase configuration is like, this is an 8-phase chip. It's a high-end 8-phase chip. It is very expensive. It's fully digital. It goes up to 2 megahertz switching frequency. If you hook up if you hook up a controller, like a compatible controller to the chip, like say an Elmore EVC2 or maybe an Infineon USB 005, like you can tweak all the things. And the thing is, like, so this is a really expensive controller, and all it's doing here is just controlling the two memory phases and the vddci. So that's your vmem over there on the +2, on the 2, and then the vddci on the +1. Then for the core and SoC power, we've got an Infineon XDP-E132G5C. So Infineon actually makes both of these chips. Like, yeah, this one's IR, but International Rectifier is owned by Infineon at this point, so same thing. Anyway, we've got an XDP-E132G5C. And this is sort of the higher end replacement of the 35217. This goes all the way up to 16 phases, and so here it's running in 14+2 phase mode. The 2 phases are, of course, on the SoC. The 14 are for Vcore, and it's got, the main thing is it's got a bunch of phases. That's a big part of what makes this chip really high-end and very expensive. And it's got a bunch of other advanced features that I've unfortunately not bothered to include in my notes. But yeah, this is just like the really big IR35217 in a way. And similarly, if you can get a compatible, a USB 005 from Infineon should be fully capable of controlling this thing. And then, of course, the Elmore EVC2 should. I believe the Elmore EVC2 also has support for the 132G5C. So if you figure out, actually, I think XFX did our job, did the job for us. I'm pretty sure this is the I2C interface right there. So yeah, you might be able to just, is it? There's a good chance some of this is I2C. There's a pretty good chance of that, just because it's located near the controllers. I wonder if maybe half split for one. No, that doesn't make sense because this seems to be ground. Is there any other headers? Oh, and then you of course have these headers over here. Fun fact: this is a header. See that? That's J403. So that's a header. I don't know what that header is for, but that's a head. Like when they have engineering sample cards, that would be a header. Oh, and then there's also a header over here, but yeah, it should, like, the I2C should hook up to this. Otherwise, you'd have to hook up to the I2C, like, somewhere in this area, which it's not impossible to do. It's just very, very annoying to do. And also, if you're attaching long wires to small SMD components, there's a very good chance that you're going to rip up the small SMD components along with their included traces. And then you're going to hate yourself. So basically, given the option, I will never ever attach anything directly to a controller. Because it is such a pain to do that. Like, I've done it. It's just like not pleasant and very, very risky for the structural integrity of the card. So yeah, anyway, the neat thing is that these are both fully digital, and potentially if somebody figures out, like, potentially it would be even possible to control these directly from Windows. Though I've been kind of wondering if it wouldn't make sense on AMD cards to just straight up, like, disconnect the controllers so that the controllers can't talk to the GPU core. Because if they don't talk to the GPU core, then the core hopefully won't know how much voltage it's getting, how much current it's getting, therefore it won't know how much power it's pulling, and then the boost algorithm will hopefully break and start behaving like not boost, because boost is dumb. So yeah, that's kind of one thing I've been well, actually, I have cards where I have disconnected controllers, but they're really old. I don't know how it interacts. Like, so I know like you can do it on like a R9 270X. Right, on a 270X, you can disconnect the controller, and the core is just fine with it. I'm not sure if you could do that on like a, well, I want to mess around with doing that on a Fiji card, and because Fiji has a bunch of weird power management stuff going on, I want to mess with it on Vega for the same reason. Bunch of weird power management stuff going on, where like even if you max out the power limits on a Vega, the card's like phantom throttle if you raise the voltage, which is just, Fiji does that as well. So that's really dumb on both of those. 5700 XT, I have no idea. I skipped those cards because they just weren't that impressive in my opinion. I mean, I was really disappointed with Vega, and then 5700 XT didn't really do anything to change that. And now we have the 6800 XT where it's like, well, you know, the performance is good, but AMD decided to lock the clock speeds. So even if this would technically just like disconnecting the controller would give you full manual control of everything, like of the well, if disconnecting the controller just completely broke the power management for the better, like it's pointless because you still can't go above 2.8 gigahertz because that's where the driver limits your max core clock. So that's really annoying. But anyway, the controllers are really good, and the card doesn't need any doublers because the controllers support as many phases as we have on the card. So, for the actual power stages, we're looking at a bunch of TDA21472s, which are give me a second so that I can write it out. TDA21472s. These are 70 amp smart power stages. And these are called smart power stages because they include a bunch of smart features that regular power stages wouldn't include, like very accurate current monitoring, though at low power draw, it's not actually that accurate. Like, it's really great once you're pulling, say, 10 amps from the power stage. And actually, that's kind of high. It works fine even down into, I believe, like the 5 amp range. But it gets really inaccurate if you're at like super low output currents on the power stages. But at high current outputs, very, very accurate current monitoring built directly into the power stages. So that's really great because you can get very accurate power draw readings from your VRM, which is super convenient for a company like AMD who doesn't believe in the use of shunt resistors. Which are ultimately a way better way of actually getting a measurement of how much power is going into your GPU. But they also, like, technically shunts slightly reduce your efficiency, and they add manufacturing costs, and on it, like, honestly, I don't care. Not having shunts is not a big deal. But yeah, there are certainly cards from AMD where it would have been like probably pretty beneficial for AMD to have actually used shunts for power monitoring instead of just kind of hoping that their VRM measurements are good enough. Anyway, so yeah, these have very accurate current monitoring built in. They also have temperature monitoring built in. And then they have a bunch of safety features like overcurrent protection, over temperature protection, short circuit protection, and a bunch of other safety features that I don't really feel like explaining, so they're not in my notes, so that I can't mention them. But there's even more safety features on these. So yeah, and that's what makes these smart, because a lot of the various safety features and, say, the temperature monitoring and current monitoring functionality, depending on how basic your power stage is, or, well, if you go all the way down to like basic DRMOS components, with those, you have to implement your own temperature monitoring, your own current monitoring circuitry. Your, like, everything is external, and it makes your circuit more complicated. And because the power stages are, well, they're not even power stages at that point. Your DRMOS components are just dumb. And so, yeah, so that makes these smart. And the neat thing about the 70 amp smart power stages is that they're also really, really efficient. So this 14-phase Vcore is capable at 1.2 volts, assuming a VRM switching frequency of 400 kilohertz, which is just what the data sheet is spec'd at. I believe the cards actually run at 500, but it doesn't really make that much of a difference to the efficiency. Like going from 400 kilohertz to 500 kilohertz, like, yeah, the efficiency is slightly worse. It's not going to be that much of a difference. But anyway, so 400 kilohertz and 5 volts drive voltage, which is just the operating voltage for TDA2147. Like that's just the power supply for TDA21472s. They don't run on other voltages. Well, they do run, but that's not in spec. You're supposed to power them with 5 volts. Anyway, So yeah, outputting 1.2 volts, 400 kilohertz switching frequency, 5 volts drive voltage. You're going to get 200 amps output. Well, the VRM is going to be able to push 200 amps into the core while only producing about 16 watts of heat. Now, what's kind of funny about this is great efficiency for 200 amps output. Like, that's a very low amount of heat. However, this is actually not the peak of the efficiency curve, because the TDA21472 power stages hit their peak efficiency at around 20 amps output, which is more like with a 14 phase like this, you hit 200 amps. Well, you hit 20 amps per phase at like 280 amps total output. So very efficient at 200 amps output, but not actually the peak of the efficiency curve. You'd be much closer to the peak of the efficiency curve at 300 amps output, at which point the VRM would produce about 24 watts of heat. So yeah, this card's really geared towards overclocking. It's just a real shame that AMD doesn't like overclocking very much. Well, the Radeon division of AMD doesn't like overclocking very much. The Ryzen side of Ryzen overclocks pretty good. Well, Ryzen overclocking is pretty decent, and it's more about the fact that like TSMC 7 nanometer doesn't scale to insane levels of power draw, rather than some AMD doesn't let you set the CPU to 6 gigahertz. They do. It just won't boot when you do that. Anyway, 400 amps. You're going to be looking at about 35 watts. Yep, 35 watts of heat output. And then 500 amps, you're going to be looking at about 47 watts of heat output from the VRM. So absolutely insane efficiency all the way up to 500 amps output, which is what you'd expect with a 14-phase VRM running 70 amp smart power stages. So, you know, for actual like real world usage, you're going to be running in the 200 to 300 amp range, where this VRM is just mega overkill. Like, you literally need to hit close to 300 amps before you even get to the peak of the efficiency curve for these smart power stages. So yeah, good job XFX on the power delivery. This is tied for first place in terms of raw current handling capacity on a 6800 XT PCB, with the RX 6800 XT Red Devil from Power Color. So yeah, honestly, when I first heard that this card was going to have a 14 phase, I thought it would be actually the exact same PCB as the Red Devil, but no, it isn't. Like, this one has a funky shape to it. There's other things that XFX has done that I'm actually a big fan of, but unfortunately, you know, AMD doesn't like overclocking, or, well, no, I'm just going to say AMD doesn't like overclocking. I don't feel like specifying that it's the Radeon division every time. Anyway, so, yeah. The VRM is basically, like, if you were going for LN2 overclocking, like, well, you can't because of the clock speed limit. But if that wasn't a thing, you totally could. This VRM is, you know, more than capable of providing insane amounts of current to the GPU core. And the other thing is, like, we don't even know that the core would scale to 500 amps, right? Like, just because you take it sub-zero doesn't mean you're going to be able to pull insane amounts of current. Anyway, moving on to the other VRMs, SoC is just more TDA21472s. Memory VRM is even more TDA21472s, and then the vddci is another TDA21472. So basically, well, the thing is, I don't know how overkill these are. Like, Vcore on this is definitely very overkill for, you know, well, any 6800 XT overclocking application until AMD removes the clock limits. But knowing AMD, they're not going to do that, because these are the same guys who broke memory overclocking on the Fiji series for no other reason than, well, it wasn't supposed to work in the first place, so now it really doesn't work. Anyway, so where was I going with it? Yeah, the thing is, the SoC VRM on here is just the same as the reference PCB from AMD, but the thing is, AMD's reference PCBs generally have good headroom on all of the main power rails in terms of capacity. So yeah, this is probably pretty overkill as is, knowing AMD's standards for reference PCB build quality. So yeah, and then the same goes for the memory VRM. Like, this is the same as reference, but it's like, well, it's not a downgrade, so, and the reference card is probably already kind of overkill, so that's fine, and vddci is also the same as reference. Also, there's, you know, a 7% core, like, memory clock limit in the drivers, so it's not like the memory overclocking is going to go anywhere, because it literally doesn't go anywhere, because the drivers won't let you, because AMD doesn't like overclocking very much. Anyway, let's talk about the good things about this card. So, you know, power delivery wise, we're looking at a card that's on par. Well, with current handling capacity wise, we're looking at a card that's on par with the RX 6800 XT Red Devil, which, as far as I'm aware, is the most powerful 6800 XT PCB that I've seen. And then we get to the sort of interesting things that XFX has done that I've not seen anybody else do. So the first thing is these two capacitors. These aren't supposed to exist. I've not seen any other card with these two capacitors right here. I assume they're for extra memory power filtering, but as I mentioned, the memory overclocking is limited to a max increase of like 7.5%. So, you know, those caps maybe actually make a difference to the memory power delivery. It's just that nobody's ever going to be able to find that out. Well, we're not going to be able to find out if they make a difference until AMD removes the memory clock limit. The funny thing is like, well, actually, well, I've had even GDDR5 cards pick up like significant amounts of memory clock speed by just throwing extra capacitors into the memory rails. So, yeah, I'm a big fan of these. The thing is just like, the memory speed is limited. And then we also have this cap over here, which I'm also guessing is for memory. And the reason why I'm guessing it's for memory, though, actually, this one could probably be for core. That is probably for memory. Like, it doesn't make sense to put it over here when you've got this, right? And this. Like, those are all empty. Why would you go out of your way to add an extra pad over here so that you can whack a cap near some memory chips that are also really far away from the actual memory VRM? Like, this makes far more sense as, like, I'm here for the memory than I'm here for the core. So, anyway, yeah, so we also get this extra capacitor, which I've not seen on any other 6800 XTs, because it's like, it's also like, I don't know how that got there. So that's pretty neat, because that could help, again, with just memory power delivery, except for, you know, memory limit. And then what's interesting to me is XFX includes this capacitor right here, but I think that might have actually just been this one getting moved. I think this is vddci. I'm not sure because I don't have the card in hand, and unfortunately, like, I don't have schematics. So the way you'd figure this out is you'd basically stab here with a multimeter, stab there with a multimeter, and hopefully that reads 0 ohms. Though, and when I say 0 ohms, I mean like 0.00, well, maybe like 0, like very low. Because the problem with most modern GPUs in terms of measurement, like figuring out measurements on them, is if you measure from here to here, that's probably going to have a resistance of like 0.05 to 0.1 ohms. Modern GPU cores don't have a lot of resistance when they're turned off. Yeah. If you go far back enough, there's GPUs that have like 10 ohms of core resistance, but yeah, modern GPUs, they basically look like short circuits even when they're fully functional. So the annoying thing is, of course, if you measure from here to literally anywhere else on the board that's connected to ground, it's gonna look like it's connected to Vcore. Unless you have a multimeter that, you know, goes into very, very low digits. Very small, well, goes far into the decimal digits. Anyway, I'm guessing this is vddci. So, and it's kind of interesting that, you know, they've decided to include this capacitor, because this one's normal, this one right here, but this one isn't normally included on most cards. So, interesting decision by XFX to you know, have that one instead of, well, I'm not sure if like it's extra or if they just moved one from over here. But yeah, so that's kind of interesting adjustments that XFX has made to the power delivery. And I'm honestly a fan of the extra capacitors. Like, extra capacitors good as far as I'm concerned. In terms of the actual capacitor manufacturers, a lot of these are APAC, but what's really weird, so APAC is a Taiwanese capacitor manufacturer, and well, they don't have as good electrical like reliability wise, they're completely fine. They don't have as low ESR specs as, say, top of the line Panasonics. Though, again, if you buy a cheap Panasonic, this is kind of like, well, then these might actually be on par. The main thing is these guys are cheaper than Panasonic, if you're going for any kind of capacitors. But anyway, what I find really interesting is like these seem to be Panasonics, which you don't normally see. Like most cards you see like one brand used absolutely everywhere. You don't see a mishmash of like, oh, some of these are Panasonic, like that's a Panasonic, and then this one's an APAC, and this one's a Panasonic. But these are APACs again, and it's just like, what? Why are, like, what? How does this happen? Why are like so? That's kind of interesting. And maybe these are more like maybe these caps were deemed more important, and so they're like some higher end, super low ESR Panasonic SKU, and then the more general bulk capacitors get to be APACs. I'm not sure, but yeah, like an interesting thing about this PCB is like, whoa, this mixes capacitor brands. You don't normally see that. You normally see like, especially because like this is literally a 470 microfarad capacitor, same as this. They're going to have the same voltage rating. The only difference between this and this should be in the ESR and maybe ESL. So yeah, interesting that you have this mix of capacitors when it's like for all intents and purposes, this one could very well be right there too. Um, but yeah, and there are actually other cards that go all APAC. Like, so I find it really interesting, or cards that go all Panasonic, one or the other. I've not yet seen a card that goes mishmash, like this one does. So anyway, that's sort of the core power delivery. Well, the output side of it. What's also interesting is XFX has added some extra input filtering capacitors. We've got this extra 100 microfarad tantalum over here, which well, looking at this power plane looking thing over here, probably covers all of this. So I think that one filters all of that. And then these two phases are just kind of left to be filtered by their multi-layer ceramics over there. And what's also interesting is they also have these two over here. Now, the thing I find very weird about it is this is really minor. Like, they added, like, three extra 16-volt caps to the 12-volt power plane. And it's just like... And they're 100 microfarads each, right? Like, they have... Well, okay, this is a 180. Actually, these are also 180s. I should have noted that down. Okay, I think I might go check that on some other 6800 XT. Like, I'm wondering if maybe they lowered the capacitance of the polymers and then added the tantalums to compensate, but I think the polymers are the same size as always, and these are just kind of extra, and it's just like... But, like, adding 300 microfarads to the 16... to the 12-volt power plane is like, that shouldn't really make much of a difference. So it's like, why? Because it definitely adds cost. Like, these are tantalum, 16-volt capacitors. Those things aren't cheap. It's just like, yeah, we're just going to throw three of them on there for reasons. They might help a little bit with power delivery. Like, very little bit. Anyway, the last neat feature that XFX has on this card is it has dual BIOS functionality. So that you can't mod the BIOS, because this is a 6800 XT and AMD, well, as far as I know, that still doesn't work. Like, BIOS modding on these does not work. Though you could maybe mess around with, like, flashing a 6900 XT BIOS to try get around the core clock limit. Still won't fix the memory clock limit, because AMD doesn't like overclocking very much. So, yeah. I think I've said everything I have to say for this card. Like, good job XFX on the PCB. I like it. We've got a very strong Vcore VRM, the typical memory power and SoC power that you'd see on a 6800 XT. We've got some extra capacitors in funky locations that I like. Well, yeah, we've got some extra capacitors in locations that I approve of, and You've got dual BIOS functionality. Oh, there's also LEDs to indicate that you forgot to plug in your power connectors. Yeah, so really solid 6800 XT PCB. Now if AMD could just like, you know, allow PCBs like this one to stretch its legs, that would be great, wouldn't it? Yeah, so that's it for the video. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. Also hoodies, which I forget to mention. And merch. That's it for the... Oh, wait, no. Yeah, so, you know, check out Teespring, check out Patreon if you'd like to support the channel. It helps out immensely. And that's it for the video. So thank you for watching, and goodbye.